This is section 5.7.1, Arithmetic Sequences. On this slide we have a bunch of vocab terms that we need to define, so let's go through these. We start with the definition of a sequence. It is a list of numbers that are related in some way. Next we have terms. Terms are the numbers in the sequence. Next is the definition of arithmetic sequence. It is a sequence in which each term after the first differs from the preceding term by a constant amount. In other words, we're adding on the same number to get the next term. The definition of common difference is the difference between each term in the sequence. So it would be the number that you're adding on to get the next term. A sub 1 is the first term of the sequence. A sub n is the general term of the sequence. D is the common difference of the sequence. And finally, we have the recursive routine for an arithmetic sequence. It is a sub n equals a sub n minus 1 plus d. Now, what the recursive routine means is that in order to find a term of the sequence, any general term of the sequence, we're going to take the term before it and add on the common difference. So you'll see this play out. The recursive routine is always used to write out the sequence. All right, so we have some examples here. Our first example asks us to write the first 6 terms of the arithmetic sequence with first term 6 and common difference 4. Okay, now remember that an arithmetic sequence is when we add the same number to each term. So in this case, they're telling us that the first term is 6 and that the common difference is 4. So 4 is going to be the number that we add on each time. So you can picture this sequence: 6, then plus 4 gives us 10, then plus another 4 gives us 14, then 18, 22, and 26. That gives us the first 6 terms of the arithmetic sequence described. All right, in our next example, it says write the first 6 terms of the arithmetic sequence with first term 100 and common difference 20. So again, we're going to start with 100 and we're going to add on 20. That'll give us 120. Then add on 20 again. That'll give us 140, 160, 180, and finally 200. Our next example says write the first 6 terms of the arithmetic sequence with a sub 1 equaling 5 and d equaling negative 2. Now you have to remember from the previous slide, a sub 1 is the first term of the sequence and d is the common difference. So d is the number we're going to add on each time. So if we started with 5 and we added on negative 2, that would give us 3. Then we add on negative 2 again, that would give us 1. Then negative 1, then negative 3, and then negative 5. And finally, our last example says write the first 6 terms of the arithmetic sequence with first term 8 and common difference negative 3. So you can see the 6 terms there. We start with 8, add on negative 3 to get 5, add on negative 3 to get 2, add on negative 3 to get negative 1, then negative 4, and then negative 7. So these 4 examples should give you a good idea of what an arithmetic sequence is when we add the same number to get the next term. All right, the general term of the arithmetic sequence. So consider the sequence whose first term is a sub 1 and common difference is d. Okay, so we're going to talk in unknown quantities here. A sub 1 is our first term. So what I have here is up above, this is our actual sequence. All right? And down below, just underneath it, I'm identifying the term of the sequence, meaning what numbered term it is. So they tell us that a sub 1 is the first term. The common difference is d, so in order to get the second term, I'm going to add on the common difference one time to the first term. In order to get the third term, I'm going to add the common difference on twice to the first term. So I added it once and then twice. To get the fourth term, I'm going to add the common difference on 1, 2, 3 times. That's why it's 3d. To get the fifth term, I add the common difference on 4 times. To get the sixth term, I add it on 5 times. So hopefully you see the pattern here. The pattern that's unfolding is that we always add on the common difference one less time than the number of the term of the sequence. Let me say that again. We always add the common difference on one less time than the number of the term of the sequence. So that's 1d, but it's the second term. This is 2d, even though it's the third term. 3d is the fourth term. 4d, even though it's the fifth term. 5d for the sixth term, and so on and so on. So if we see this pattern and we understand it, we can write it out in an equation. So down here it says, therefore, a sub n, which is the general term because n can be any number, a sub n of an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 d. And again, what this is saying is we take the first term, we add on the common difference one less time than the number of the term we're trying to find. So if we're trying to find the nth term of the sequence, we're going to add the common difference on n minus 1 times, one less time than n. The arithmetic sequence, or the arithmetic formula that you see down here, is used to find any term of the sequence without having to write out all the terms before it. As long as you know the first term and the common difference, you can find any term of the sequence. So let's take a look at some examples. Our first example, it says find the 8th term of the arithmetic sequence whose first term is 4 and whose common difference is -7. Now, of course, you could write out the first 8 terms of this sequence. But let's use this example to understand the recursive formula from the previous slide. So we start with our recursive formula. A sub n equals a sub 1 plus n minus 1 times d. Since we're being asked to find the 8th term of the sequence, we know that this n is going to be 8, so a sub 8. And this n will be 8. They told us that a sub 1 is 4, and that the common difference is 7. Or, excuse me, -7. So we know everything that goes into this formula. So let's plug it in. There we go. Now, all we have to do is simplify. Do some basic arithmetic and find out what the 8th term of the sequence is. We end up with -45. If you wrote out the 8 terms of the sequence, we could verify this. There's our first term, 4, right there. We add on negative 7 to get negative 3, add on negative 7 again to get negative 10, add on negative 7 over and over again until we get to our 8th term of negative 45. But again, what the recursive formula does is it allows us to jump right to the 8th term without writing out the 7 terms before it. All right, let's look at our next example. Find the 9th term of the arithmetic sequence, whose first term is 6, and whose common difference is negative 5. So once again, we start with our arithmetic formula, or our recursive formula. We plug in what we know. They told us that the first term was 6, that the common difference was negative 5, and that we were finding the 9th term of the sequence, so n equals 9. Now do some basic arithmetic, and you get the 9th term to equal negative 34. Now you might be thinking to yourself, well, I'm not going to use this formula, I'm just going to write out the terms of the sequence. Because in our first example I was finding the 8th term, and in our second example I was finding the 9th term. Well, you're going to have to be able to use the formula, because there will be problems where they ask you to find the 50th term. And you're not going to want to write out all 50 terms of the sequence when you could simply use an equation to find the 50th term. All right, so this has been section 5.7.1 on arithmetic sequences.